Muy buenas tardes para todos, nuevamente. Primero que todo queremos agradecer a Reliable, a David, por acompañarnos el día de hoy, por compartir con nosotros sus conocimientos. Queremos agradecer a Antonio, que también nos está acompañando el día de hoy, y a Jesús, que normalmente ha sido el vínculo directo con Raci de alguna manera, y que ha promovido que hoy tengamos esta participación y esta presentación muy interesante y muy productiva para todos. Quisiera pedirles también que si hay preguntas, las hagamos todas y aprovechemos a David Invita al máximo. Yo creo que tenemos un espacio interesante de unas 2 horas y 10 minutos, algo así. Entonces aprovechémoslo, las preguntas, las dudas, lo que queramos compartir, pues aprovechémoslo al máximo. Y bueno, aquí le doy la palabra a Antonio.
Muchas gracias. Miren, hablando del rey de Roma, llegó Jesús López. Nosotros somos Reliable Automatic Sprinkler, somos fabricantes de rociadores. De rociadores, válvulas, en general equipo que va desde el sistema de bombeo hasta el último punto, ¿no? Todas tenemos accesorios, tuberías y todo lo que tiene que ver con esto. El día de hoy pues estamos muy agradecidos por recibirnos aquí y porque David Asplund tiene bastante experiencia, tiene más de 40 años en la industria de los rociadores. Entonces él nos va a mostrar este tema acerca del almacenamiento y nos va a mostrar unos videos bien interesantes de investigaciones que se han hecho. Entonces no solo es platicar de productos, sino también compartirles a ustedes el conocimiento de por qué se hacen las cosas y por qué va cambiando el mercado, por qué van cambiando las alternativas, la tecnología, todo en base a la ciencia, como él nos va a mostrar más adelante.
Bueno, buenas tardes a todos, bienvenidos, muchísimas gracias por el tiempo, gracias Hugo, a la asociación por darnos el espacio. Bueno, como dijo Antonio, muy contento de estar acá, de tener a David. David, como les comentaba Antonio, tiene 40 años en ingeniería contra incendio, ha formado parte de varios comités de NFPA, así que él junto a otro grupo de ingenieros en nuestra empresa forman parte de esos grupos, de esos comités, y nosotros fabricamos en base a los cambios que se vienen en la norma. Entonces, bueno, es muy interesante, bueno, espero que lo aprovechen y, como siempre les digo, tratar de ser lo más didáctico posible. Si tienen consultas, si tienen preguntas, eso es lo que a David le gusta más, que interactuemos y, bueno, estamos acá a aprovechar para sacarse dudas, para aprender, además de ver nuevas tecnologías y de ver el futuro en esto, sobre todo en almacenamiento, pero también si tienen dudas de lo que sea, aprovechemos que está David acá para hacer las consultas. ¿Okay? Bueno, muchísimas gracias y bueno, le doy paso a Mr. Asplund.
You got the mic on?
Sí.
So you need this.
Hola, buenas tardes. Me llamo David Asplund. Perdón, yo no hablo español. So we have translator working. We will talk today about trends and advances in fire sprinkler systems for storage occupancies. I always start with a photograph of fire. It seems as contractors we don't get to see and deal with fire very frequently. But I love this photograph. People always ask me 3 questions about this photograph. Number 1, did I make the putt? See, I made the putt. Number 2, they ask if my wife got out of the house okay. And I say, see, she's fine. And number 3, yes, the divorce is going well because now there is no house to fight over. So it's all very good. So why is storage different? Storage is different because of the vertical component we have in the fuel loading in a building. Fires typically start near the floor and they go rapidly vertical towards the ceiling, making it a very high challenge to get the the spray discharge from our fire sprinklers down to the root of the fire where the water is needed most. This is a typical example of a fire in a fire test, and you can see how difficult it would be for spray discharge from the fire sprinklers to get down here where it's needed most. So we will start by watching a simple fire test of some mattresses. This is at the Factory Mutual Test Lab. This was sponsored by the Mattress Manufacturers Association. They put a flame spread on the surface of their mattresses, thinking that they don't burn, and that we fire sprinkler contractors are overprotecting mattresses. So we will apply a 0.60 gallon per minute per square foot density over this fire. Very large sprinklers with a lot of water density coming down against this fire. So as you can see, thank you, grasses. As you can see, the fire is growing very rapidly up the vertical aspect of the fire. The flame spread rating on the mattress is doing nothing to prevent the fire from growing. Sprinklers are open now. We're discharging water on this fire. It's having very little effect. We're seeing some smoke, some steam, some obscuration from the spray discharge, but the fire is continuing to grow unabated. It will completely consume the fuel package here during this test. This test is quite old, from December of 2007. It was conducted shortly after a tragic fire in Charleston, South Carolina, in a building called the Sofa Mart. 7 firefighters died in that fire. That building began changing from furniture to mattresses. The mattresses caught on fire without improving the fire sprinkler system. The building collapsed and we lost 7 lives in that fire. So how well do fire sprinklers work? There had never been a multiple loss of fire in a fully sprinklered building when the source of the ignition is not an explosion and the source of the ignition or the system is properly maintained with the valve being open. That's a remarkable success story or a success statistic of our fire sprinkler systems. 96% of fires in fire sprinklered buildings are completely extinguished with 6 sprinklers or less opening. Again, this is a very remarkable performance statistic. In the 125 years we've been keeping statistics of fires in sprinklered buildings. Storage occupancies, however, have less of a success rate. They perform at around 78%. This is a statistic from the National Fire Sprinkler Association in the United States. The reason being is something like you just saw, someone changing the occupancy in a building, from furniture to mattresses, and not changing the fire sprinkler system, changing the commodity or the methodology that things are stored, and it will overcome the performance of the fire sprinkler system. Now, I want to be very careful and define a failure as not the building burning down, but as a fire growing to a size that opens more fire sprinklers than we calculate in our hydraulic design program. So if we calculate 20 or 21 sprinklers or 12 ESFR sprinklers, as soon as we open 1 more sprinkler beyond what we've calculated, that is considered a sprinkler system failure. not the building burning down. So, codes and standards are written and revised as a result of catastrophic events. You just saw a fire test that was performed a few months after a very fatal fire in Charleston, South Carolina. Codes and standards are written in the blood of the victims. Since early times, the first building code back in Mesopotamia was if a contractor builds a building and it falls down and the occupant loses his life, we will kill the contractor. That was very simple, easy building code. So there have been more changes in storage protection of fire sprinkler systems in the last 5 years than in the previous 50 years. So it's very difficult for us to keep up with these changes. It's changing so rapidly. But the bottom line is fire sprinklers work. We sell a product, you install a product that works. Something to be very proud of to be in this industry. So we will start some definitions of storage. Storage by the NFPA standard is defined as being in excess of 12 feet or 3.7 meters in height. If it's less than 3.7 meters in height, it's simply ordinary hazard group 2 occupants, very similar. So the number one thing to define in our minds is that storage is defined as being tall or is in great height. The second thing to consider is the class of commodity. How volatile is the fuel source in the building? How rapidly will it burn? How much heat release will it give off? Class 1 is a very simple, non-combustible material stored on a wood pallet. We don't see much Class 1 commodity anymore. We start with our burn tests with this standard Class 2 commodity. It is a 5-sided steel drum with 6 layers of corrugated cardboard carton on a wood pallet. So we light this under a calorimeter in the test laboratory to measure the heat release rate. Class 3 commodity, again, has more heat release rate. It are these paper cups with the wax coating so it holds liquid, upside down in divided corrugated cardboard cartons on a wood pallet. We are allowed small percent by volume of plastics, group A or B, 5% by weight or volume. This is not very much plastic content. Often we see the recycled cardboard have more than 5% content of plastics by volume because we recycle so much. The magazines and things that are sent to us in a plastic bag, we put that in the recycle bin. It all gets ground up and recycled into paper. So paper and cardboard specifically has a water repellent aspect to it. So it has become more volatile. Class 4 commodity is an alternating between the paper cup and a plastic polystyrene cocktail glass. We have different quantities of group A and B plastics that are allowed, 5 to 15% by weight, or 5 to 25% by volume. Again, this is a very small quantity of plastics that are allowed in this. A group A carton, unexpanded plastic, is represented by all of the packaging being filled with the crystal polystyrene cocktail glasses. This is a very sturdy or stout cup. It's not a solo cup, a red beer glass, if you will. A very strong cocktail cup. There'll be acrylic or butyl rubber, natural rubber, thermoplastic, polyester, polyethylene, like milk cartons, plastic water containers. Polypropylene, polystyrene, which is what we see here, and polyurethane. Polyurethane is the foam that we see in much furniture and in automobile seat cushions and things. Now we arrive to the exposed, expanded plastic commodity. Exposed or uncartoned And we call this an EEP, for exposed expanded plastics. So now I'd like to show you how well this burns. This is the calorimeter that I spoke of earlier. It's at Underwriter Laboratories in Northbrook, Illinois. We're going to ignite these 8 pallets of expanded Group A plastic, and it will burn free until all of the fuel is consumed. You may know these polystyrene expanded plastics as a meat tray. If you go to the grocery store and buy ground beef or chicken, it's normally on an expanded plastic tray. A coffee cup, a white styrofoam coffee cup. We have no sprinkler discharge against this fire. It only takes a few moments before it's fully involved. These types of plastic are a petroleum product. It is virtually a solid gasoline, if you will, with an oxidizer in the foam cells to add to the combustion process. Incendio grande, huh? No translation? Okay. During the test process, they will spray water around the perimeter. You will see the floor being a little wet. This is just so we channel the heat up through the calorimeter and we don't get any heat escaping out of the sides of the test facility. So now we have a definition for mixed commodities. What we see a lot in the world, where we have small quantities or bits and pieces of everything you can imagine being stored. We have to protect these as if the whole building is with the highest classified commodity, because a very few pallets of storage of high class commodity can overtake a sprinkler system and burn the building. We're allowed up to 10 pallets for 40,000 square feet. Where a higher hazard commodity is defined to a designated area and protected as such, we can lower the rest of the ceiling demand. We see this a lot in big box retail, like Home Depot. If you go into a Home Depot and you look at the aerosol spray paint cans, and you look in that rack, you will see they have put in-rack sprinklers just where their most volatile products are stored. So they don't have to overprotect the entire store, and they can have an economical sprinkler system. Just have the in-rack sprinklers located where they need to do the heavy lifting of the fire protection. This has given us a great idea for the future. But before we talk about the future, I'd like to talk about the history of fire sprinkler performance. So to know where we're going, we have to learn where we've been, where we've come from, and how our products have evolved. When I got into the business, a box of fire sprinklers were metal objects in a corrugated cardboard box with the nesting to keep them safe. It was a very typical Class II commodity. Today, fire sprinklers with glass bulbs have an unexpanded plastic protective strap, and we ship them with this expanded polystyrene plate to as a shock absorber to keep them safe. We manufacture very high quality sprinklers, but it doesn't do us any good if we can't get this quality validated product in our customers' hands in the same condition it leaves the factory. So changing our packaging has changed our commodity classification. These polystyrene plates represent 14% by volume expanded plastic. So now a box of fire sprinklers is considered a cartoned unexpanded plastic. The same product inside, but the packaging has forces. So we need to think of everything that's in the box, not just the product. So changes in industrial practices occurred throughout the world after World War II. We began building buildings out of steel. Steel was stronger, it was lighter, more economical, and we could go taller with our buildings. We were allowed to begin using fork trucks to mechanically move pallets, and we could go much taller than we could with a human and a ladder. This added that vertical component. But we didn't change our sprinkler systems, and this is what a fire looked like after we started doing this with a typical antiquated sprinkler system, a pipe schedule sprinkler system with half-inch sprinklers. So in the 1950s, from these catastrophic losses, we began to develop direction to our sprinklers, a standard spray upright or a standard spray pendant. We also developed a sidewall, but it's the uprights and pendants direction that gave us a better performance for protecting storage occupancies. But still, in the 1950s, with this technology, our fire tests would open many more sprinklers than our water supply could handle. So again, we needed the next generation of improvement to our design, or a performance-based in our design. So the 1960s, the density area thought process was developed. If we have more fuel in the building, we have more water coming down, and we can classify it by the fuel or the expected heat release from the fire. And so we classified our commodities from 1 to 4, and we picked 20 feet of storage height as the baseline. And then we have these various curves to help match the water supply. If we had a good water supply, we could pick this density area, or we could go up, have more flow and less pressure, depending on where the water tank was. Most systems were gravity fed, so that was the idea behind the curve. If we had storage greater than 20 feet, we increased the density by up to 175% based on the storage height, but we were very limited to the storage height. After this design density thought process came through, manufacturers came out with a whole bunch of sprinklers to apply this density to these applications. So that is the beginning of our industry getting more complicated. In the 1970s, Viking and FM Global developed a thought process of water penetration through the fire plume using large water droplets. This led to a CMSA sprinkler, or a control mode specific application, a large drop sprinkler. This is the first time we started designing a water droplet to have mass and momentum to penetrate against the fire plume. First thought to design a droplet rather than a quantity of water. Look at it microscopically. And then, of course, we developed a whole bunch of CMSA sprinklers to accomplish this task. Our design format changed from density area to a number of sprinklers at a minimum pressure. The 1980s, we saw innovations in residential fire sprinkler technology. We invented the first residential fire sprinkler. The idea or the thought process was to have a very fast responding element so we could deliver the water there much sooner while the fire was still small. It's much easier to take care of a problem while it's small rather than when it's big. This technology with residential sprinklers was the first step in developing an ESFR, or a suppression mode fire sprinkler. Our thought process married with this fast responding element and the large droplet size that was developed in the 1970s. If we can marry these two innovations together, we can have a new form of fire sprinkler. So we began putting real science into the fire protection problem. When we look at this, this stands for actual delivered density concept. The RDD stands for required delivered density. So this is our quantity of water on the left versus time on the right. So very early on, while the fire is very small, the very first sprinkler that operates at the pump pressure or the static pressure of the system, much higher than the design pressure. So it delivers an actual density much larger than is required to put the fire out. So as time goes on and we get more and more sprinklers open, our pressure begins to deteriorate or even out throughout the system. But this whole area between the required density and the actual density is now defined as the suppression zone. So if we design products to deliver this at this stage of the fire, during this timeline, we achieve suppression, hence the name ESFR, or suppression mode sprinklers. So of course, when we get this new idea and we get one sprinkler, then we manufacturers have to make it more complicated and make a whole array of sprinklers to achieve this task. So the trends that we talk about are increasing in orifice size or K factor, much quicker response time of the element, much smaller element, and then a deflector that is designed to deliver the large droplet to the root of the fire, rather than just a general spray pattern everywhere. So now we need an improvement in our terminology, or the names that we call sprinklers. We originally had the control mode density area from the 1960s. And we had control mode specific application. The first time we used a pressure and a number or a quantity of sprinklers as our design criteria. And we have suppression mode sprinklers. Now it's getting more complicated. You have a building with storage in it. Which one do you select? Which one do you choose? So FM Global began doing research on the differences, or really the similarities between sprinklers. Are control mode density area sprinklers equivalent to a control mode specific application sprinkler if their properties or their attributes are identical? So we can see by this photograph, the sprinkler on the left is control mode density area. It looks nearly identical to the control mode specific application sprinkler. The only difference is the chrome on the deflector, which is just there to identify the sprinkler as being special. But because their K factors are the same, their temperatures are the same, the response time of the bulbs are the same, the deflectors are the same. So it's those properties that define the performance characteristics of the sprinkler. If the properties are equivalent, the sprinklers are equivalent. And this goes true if you are comparing a Tyco sprinkler to a Viking sprinkler to a reliable sprinkler. If these properties or attributes are equivalent, then the sprinklers are equivalent in performance and can be used interchangeably. So FM did a full-scale fire test comparison, 16 total tests, but 8 side-by-side comparisons, always with double row racks, class 2 to standard plastics, K11.2 upright, nominal 160, standard response. And at the end of the day, each one of these tests, $100,000 plus. So nearly $2 million was spent to determine this. And the conclusion of the test is that they're equivalent for design purposes, provided that K factor, orientation, temperature, RTI, or response time index, and the spacing of the sprinklers are identical. This was a quantum leap in moving our industry forward and innovating and simplifying how we do our designs for protecting storage. So now all these cumbersome names have just evolved into a sprinkler category called storage sprinklers. Use a single common installation method and it reduces the protection criteria, simplifies the design aspect for the engineer. The key attribute, like I said earlier, is to take the water from here and get it down to the floor against the products of combustion that are fighting us so hard in getting the water down where it needs to be. So the number one thing to look at is the K factor. We have evolved from the half inch, 5.6, up to the 1 inch, 25.2. The response time index is extremely important. You can see here close-ups of a standard response link, very thick, it's heavy, it's got high thermal mass. Our quick response or fast response thermal element is very thin, has a very low thermal mass. Same attributes occur with bulb sprinklers. This is the 3 millimeter diameter bulb on the left, 5 millimeter diameter bulb on the right. We have quick response on the left and standard response on the right. So orientation is simple, things we've known for many years. Pendant sprinklers and upright sprinklers. Pendant sprinklers have a slight advantage over upright sprinklers. If you look in the tables for upright ESFR, you see that sometimes their height is very limited. Where with a pendant sprinkler, we can go up to the very tall limits of ceiling-only protection. Temperature rating. So we have a standard black element on the left, but the blue paint on the sprinkler indicates a 286 degree temperature rating. So a movement towards a single design format is testing. So FM Global conducted a series of tests with 30-foot ceiling, again the double row racks, cartoned unexpanded plastic commodity. This is very important because they looked at the world around us and most of the products that we store, most of the products that we as consumers purchase, and as such warehouses keep on the shelf, are cartoned unexpanded plastics, whether it's a box of modern sprinklers, your cell phone in a cardboard package, your television, the computer, projector, so many things that we buy and consume of electronic devices are in this category. So if we test this category in a broad sense, we are testing most of the storage commodity that exists in the world. To make the test equivalent, we put the igniter directly under one sprinkler. So in test number 1, we deliver a 0.8 density. This is an enormous quantity of water. If we were to put a dam up at the spacing of this sprinkler, in 1 minute's time, the water on the floor would be well above our ankle, halfway up to our knee in 1 minute's time. A very large quantity of water. Test number 2, with our new technology and our new thought process of designing the droplet size, we will deliberately reduce the total water delivered by 25%, down to a 0.60 gallons per minute density. And we asked how many sprinklers will open in each fire. This is test number 1. Please note
The igniters are being lit.
an FM Global test.
We have ignition.
8-foot aisle, 20 feet of storage, 30-foot ceiling height.
105, flames starting to lick out into the east base, the main rack at the 3rd tier. 110, flames 7 to 8 feet above the top of the array. 1 minute 18 seconds, the first sprinkler is operated and flames are being driven back down to below the top of the third tier. 1:30, flames on the east face at primarily the second and looking out at the third tier. Flames still appear to be still driven back down into the lower tiers. 1:45, flames have again reappeared above the top of the array and extending above the top of the top tier at least 5 to 6 feet.
The fire grows vertically against the spray discharge. We have one sprinkler over.
2 minutes, flames no longitudinal flue space ascend from the top of the bottom tier onto well above the top of the array. Flames increasing on the east face of the main rack at the second, third, and partially spreading onto the top tier. 2:16, flames not yet looking out onto the west face of the main rack. They are increasing on the east face, and there's some smoking of the target at 2:25. 2 minutes 30 seconds, flames still extend at least 5 to 6 feet above the top of the array from the longitudinal flue and several feet from the east face. 2:45, flames just starting to look out onto the west face of the main rack, second and third tiers. 2:50, fire in the east face, partially covering the center 2 pallet loads at all tiers. 3:10, increased smoking of the target.
Still only one sprinkler operating after 2 minutes.
3:20, fire continued to intensify, especially on the east face. And 3:25, the second sprinkler operated to the east of
That
ignition.
sprinkler is 20 feet away from our fire.
Increased
The first ring
smoking of the
sprinklers
target.
is having water cooling those sprinklers.
3:35, ignition of the
water
target at the second tier.
mushroom.
Flames have been intensifying in the west face and now extend from the top of the bottom tier to above the top of the array. 3:43, another sprinkler operated, followed by another. 3:48, found that several more sprinklers operating. Flames on both faces of the rack still extend above the top of the array. Another sprinkler operated with ignition of the target at the third tier. However, the fires on the target are very light. Sounds like several more sprinklers just operated at 4 minutes, followed by 1 or 2 more. 4:07, much smoke being driven down to floor level, securing much of the fire room. 4:15, control room reports 20 sprinklers operating.
Okay, no more video because it is only smoke, no fire. They run the test to the 5-minute mark, and at 5 minutes, 25 sprinklers are open, even though we only calculated 20 in our hydraulic design. So this is classified as a sprinkler failure. Even though the building did not burn down, it eventually controlled the fire. But what we see is that the droplets from these K11.2 sprinklers were small, and the fire plume was carrying the water droplets away with the products of combustion. That spray discharge was landing on the first ring of sprinklers, cooling them, preventing them from operating and helping to control the fire. So test number 2, same storage, same ceiling. We've made the test more difficult with a 4-foot aisle. We've reduced our density by 25%, but we are using new technology here. These are the sprinklers that are located in the new Chapter 21 of the NFPA 13 standard. They are extended coverage storage sprinklers, fast responding element, and a K factor of 25.2. And they are extended coverage, so they are further apart, which makes it more difficult from the water mist or the small droplets to be carried away and land on an adjacent sprinkler.
And we have ignition. At 2 seconds, flames reach the top of the first tier commodity and are looking at the base of the second tier commodity. At 17 seconds, flames are emerging out of the top of the second tier commodity. 25 seconds, flames enter the flue of the third tier commodity. And flames are now into the fourth tier at 31 seconds. And out the top at 34 seconds. Flames are beginning to spread laterally, and activation of the first sprinkler at 31
half the
seconds.
time as test number 1. It's due to the quick responding.
Flame heights are about 23 feet in total height. We're at 48 seconds now. Flames have been driven downward slightly.
Notice the large droplets of water.
We're at 55 seconds, and small flamelets are
test.
emerging out of the ignition flue on the eastern face of the main array. Flames are being driven down further. We're at 1 minute, 5 seconds. At 1 minute and 15 seconds, it appears as though the fire is contained to the first 2 tiers of the main array in the ignition region. 1 minute, 25 seconds, there's a very light gray, whitish colored smoke emanating from the fire area.
You've had sprinkler discharge for 1 minute and the fire is virtually contained. This is the point when the water flow switch contacts close. This is where we get our first alarm. And the fire event is nearly over.
1 minute, 55 seconds. The fire continues to be contained within the first 2 tiers of the main array. Two minutes and 20 seconds, and a light gray, white haze is engulfing the array area of the test pad. No flames are visible at this point. We're now at 2 minutes and 35 seconds. Three minutes and 50 seconds. Smoke continues to be generated, indicating that there is indeed a fire there, and it is possible to see about small flamelets about 1 foot in height emanating from the top of that first tier commodity. And at 5 minutes, the test is terminated. Post-streams are applied.
So much different results with test number 2. Only 1 sprinkler open can nearly extinguish the fire. The fire that was still there after 5 minutes, the fireman could come in and literally pat out with his glove. He wouldn't need more water. It was hidden underneath one of the pallets and couldn't get water spray on it. But remarkably different performance in the 2 different styles of sprinklers. So since FM Global is primarily an insurance company, they're very interested in calculating the loss in dollars of these 2 fires. The first fire sprinkler system test opened 25 sprinklers, K11.2, standard response, standard spacing. Test number 2 opened 1 sprinkler, which is pendant, K25EC, quick response element at 14 by 14 spacing. The loss calculated for the first fire, $6.25 million US. The loss for the second fire was calculated at $1.5 million US. Remarkably different. It's that kind of performance from the fire test that inspired the NFPA 13 committee to adopt this new science and this standard. We must spend a lot of money, do a lot of testing. That's where Chapter 21 came from. So the test shows that the larger K factor delivers the larger droplets. K factor and droplet size are directly proportional. Faster response time means that there's smaller fire to control. But density does not mean what we thought it did. For 50 years we've been using density. My whole career, I'm trained on density. Now I'm an old dog, and I must learn new tricks for the future. So this is an example of a data sheet from FM Global Tables 8-9. And you can see they list the commodity, they list the building height, and they give the best choices in green. These are the choices that have the best performance with the smallest amount of hose streams and the smallest duration of the water supply. All of these has been tested. Unlike our densities, where we only tested a few and we extrapolated data, each and every one of these was tested by FM. So this is real 21st century science in our fire protection industry, something that we didn't see in the 1960s or in the 1970s. So no storage heights, no aisle widths, everything is based on 4-foot aisle. The future is having robots pick things and put them away so that aisles get more narrow. There's no favorable or non-favorable conditions to put in our design. The number of sprinklers in the design criteria leads to less hose stream and less water supply duration. We see this here. This is the ESFR criteria, up to 12 design sprinklers, 250 GPM hose, 60-minute duration. We also are allowed to eliminate the smoke vents at the ceiling. So with the extended coverage sprinklers, with up to 6 sprinklers in our design criteria, again, 250 GPM hose, 60-minute duration. This dramatically reduces the quantity of water required to protect these storage occupancies. So our future vision for data sheet 8-9. Eliminate the 10-foot limitation on storage above the highest level of in-racks. We're going to do research where a level of in-racks is a virtual floor, and each level of in-rack has to do the heavy lifting of fire protection, and the ceiling will only protect what's above that highest level. Establish new in-rack protection schemes based on the K factor and the available pressure. Eliminate the requirement to balance ceiling and in-rack demands together. This will dramatically reduce our water demand. It will be either or. Ceiling sprinklers doing the work or the in-rack sprinklers doing the work. Compared to previous standards, the new technology and design philosophy will lead to a lower number of sprinklers in the design requirements. Saves water, saves money, smaller pipe size. Lower hose demands, lower duration demands. Extended coverage sprinklers will lead to generally fewer sprinklers being installed, fewer branch lines, less overall piping, fewer connections, less installation labor. Very cost-effective solution. Once again, it's our industry being friendly to the construction industry. If we, as fire sprinkler manufacturers and installers, can keep our costs very consistent per square foot, the construction industry will be very friendly to us in return for doing such a good job, and we will see more and more buildings in the future equipped with fire sprinkler systems. We have a vision that the best years of the fire sprinkler industry are still in front of us, not behind us, because of this innovative technology that keeps costs under control for the developer, the end user, the owner of the building, and does a better job of putting the fire out, keeps his insurance costs down. So through these changes, NFPA, FM Global, and Reliable are poised to provide the industry the most effective protection options that are simple and cheap and a more sustainable choice. This is important in the future. They're going to do a better job and save water. So what else is new? We talked about our history of where we came through to chapter 21. But what is this next generation? What does this future vision look like? So we have a glimpse of what the 2019 edition of NFPA 13 will look like. It include something called Option 3, Chapter 25.8.3. This will include new or the next generation of in-rack sprinklers. But again, we look at our history. We see where we've come from with ceiling only. From 30 feet or 9.1 meters, we use a Chapter 21 sprinkler and have an 830 gallon per minute demand. And we can go all the way up to 48 feet of ceiling height with the K22, K25, or K28 ESFR, but we need nearly 2,000 gallons per minute to protect these buildings. So we're capable, but at what cost from the water supply? So there are three driving factors to return us to in-rack sprinklers. 30 years ago, FM Global tried to eliminate in-rack sprinklers from ceiling only. They invented the ESFR. FM Global was having more loss as an insurance company from water damage than they were from fire damage. So it's a natural progression to invent something that got rid of the water damage. But are they coming back? This is a good example of the effect of e-commerce has on our society. Has anyone purchased anything from online or the world's largest online retailer? Had it delivered to your home? Very convenient. This is what a fulfillment center looks like. It's called a rack-supported structure. There is no building. The racks are the building, and they just put the skin on the exterior of the rack. These are 120 feet tall. So it forces us into in-rack sprinklers. We can't do it from the ceiling only. These fulfillment centers have robots that put the product away and retrieve the product. And robots don't break in-rack sprinklers. So that is an advantage that allows us to go back to in-racks. Number two, it's a more volatile world that we live in. With the polyurethane furniture, the aerosols, the polystyrene plastics for packaging, tires. So methods of storage, closer together, and the commodity are forcing us with higher challenge fires to change our approach to protecting these. I was involved in a project a few years ago, storage of automobile parts. And I grew up in a time in America where automobiles had chrome bumpers, steel bumpers, and they were shiny and they sounded good and they were hot rods. Today, parts for automobiles, body parts, bumpers for Toyota, Honda, Subaru, Kia, all the cars we see with the low impact collision rating. They're made from expanded polystyrene with a vinyl clad to get the color. And they are stored very tall in buildings. The robots will grab the red bumper or the white bumper, the front bumper, the rear bumper for the automobile repair shop. This is storage of exposed expanded plastics. They don't even put them in cardboard cartons. They're in a plastic sack with a barcode so the robot can read which bumper it is. Car bumpers. Who would have thought? The third driving factor. It's a very thirsty planet. It's not that we have less water. It's that we have many more people, many more thirsty people to drink the available water supply. Clean, safe, fresh drinking water. So we are seeing in places like Australia. 6 years ago, Reliable opened a distribution center in Australia. I had the privilege to travel all of the Australian continent for a month visiting our customers and looking at sprinkler systems everywhere I go, because that's what I do. And in Australia, they don't have very many people. It's a very big place with very few people. And part of the reason they don't have very many people, they don't have the water supply. It's a desert. All the people in Australia live in a very narrow band around the entire continent. That's where the water is. And so all new sprinkler systems in Australia are fed with a tank and a pump. And the tank is filled with recycled water, harvested rainwater, gray water effluent. And whenever they test the sprinkler system or the pump, it goes in a cycle. It goes right back into the tank so that they can use it again. The drinking water in Australia is too valuable. It's chlorinated, it's fluoridated, and it's much too valuable to supply a fire sprinkler system. And so when we see places like Australia and California, where I live, in drought, and the value of water go up, and the new green building technology come out to save light, save energy, we have this as our future vision. It may not be here today, but very soon, and it will be the future. So inventing products that do a better job with less water is our future vision for the fire sprinkler industry. So again, we go full circle back to our exposed, expanded plastic. The most volatile commodity that we can burn is where we're going to start our testing. And because in the 2013 edition of NFPA 13, when we wanted to protect an exposed, expanded Group A plastic, we would go to our decision tree under Group A. If it was cartoned, we had methods to protect it. But if it was exposed, expanded, our reference, our NFPA 13 simply said, outside the scope of this standard. We have no direction for you. So where do you go? How do you protect this? So that inspired the Fire Protection Research Foundation, which is a subsidiary, an arm or a branch of the NFPA. They collect money for research and development, and they decide where that money is best spent. Because we have no guidance in the standard for exposed expanded plastic, they picked this as a good research project. So here's test number 8 of exposed expanded plastics at UL Laboratories. We have vertical barriers at 16 feet on center using K25 ESFR. It's a very bad fire. See the oxidizers pushing the commodity out. First sprinklers open here and just make the fire angry. Force it out the other side of the rack. So at the end of this test, 8 sprinklers were open. That gives us our 12 sprinkler hydraulic demand. There's always a 50% safety factor from the number of sprinklers we open. It took 8 tests to collect enough data to only have 3 successful tests. Many of the tests opened 12, 15, 20 sprinklers. So at the end of the day, the 2016 edition of the NFPA 13 now has criteria to protect exposed expanded plastic with vertical barriers, but we're limited to 40 feet, 12.2 meters, 35 feet of storage, the K25 ESFR, 60 PSI start pressure. We now need 2,600 gallons per minute. We can do it, but again, at what cost? A very large quantity of water to protect us. But it was the start of the research project, of the thinking on how to protect this new world we live in. So are in-rack sprinklers better? Of course they are. Anytime we can reduce the line of sight from the sprinkler to the origin of the fire, we get much faster operation of the fire sprinkler, and we have less distance for the water droplets to travel, or less opportunity for them to evaporate in the fire plume. We can also do things like have storage under sloped roofs, retrofit existing buildings. There's a lot of advantages to using in-rack sprinklers. FM Global has known this for many years. They have a scheme called 8-9A. They think they can protect anything with this, and they virtually can. They have level of in-rack sprinklers at every 10 feet. 10 feet, 20 feet, 30 feet, They have longitudinal flue space sprinklers. They have transverse flue space sprinklers. They have sprinklers at the face. So you will see a fulfillment center, very, very tall. We'll have 1,000 or 1,200 sprinklers at the ceiling and 10 to 12,000 sprinklers in the rack. So we can do it. But again, at what cost? So when we look at this, we see the face sprinklers. They do a very good job. They're very expensive to install, but they also provide many, many targets for the loading and offloading of the storage in the racks. So we wanted to explore the opportunities of what the next generation of in-rack sprinkler may look like. And it looks exactly like our Chapter 21 ceiling sprinkler. So we are taking existing product that we know works very well, and we are testing new applications for existing product. So you don't have to buy another sprinkler. We don't have to make another sprinkler. We just have new applications for existing sprinklers that we already have. So it is a K25 extended coverage quick response sprinkler. It's a very flat spray pattern, and we're using it under a horizontal barrier. This horizontal barrier is not a fire barrier. It's just a heat collector to speed up the operation of the fire sprinklers. The extended coverage, or the very flat spray pattern that this deflector gives us, allows us to get very close from the sprinkler deflector to the top of the storage. And the water droplets still spray wide and far and are very large with a lot of momentum. And we'll see in a few moments a fire test where we actually see the water cascading all sides of the storage, so it does a very good job of wetting our commodity and preventing the horizontal spread of the fire. 1, 2, 3, 4, 5, 6, 7 fire tests. I think now today we have 10 or 11 fire tests with this product. But we have 2 advances, one for exposed expanded plastics and one for carton unexpanded plastics. So we will look at the exposed expanded test first, because simultaneously the Fire Protection Research Foundation was doing their K25 ESFR testing while we were doing this testing. So we picked a 40-foot ceiling height, 35 feet of storage. We used a K17 ceiling sprinkler. We made the assumption that there are many existing buildings in the world that are 40 feet tall that already have K17 ESFR fire sprinklers in them. So what if an owner or developer wanted to move a commodity into this building that cannot be protected with K17 ESFR? Would they need to take the entire sprinkler system out, remove and improve their water supply, their pump, their tank, put in K25 ESFRs? Or is there something that we can do, like Home Depot, and just put in-rack sprinklers where they're needed? Have the in-rack sprinklers do the heavy lifting of the fire protection. The problem is solved, and we can salvage everything that we have at the roof. Again, being very friendly to the construction industry and the developers and the building owners from a cost standpoint. Solving a problem and not having to spend enormous quantities to do it. We're using our K25 extended coverage pendant, our Chapter 21 ceiling sprinkler, in the rack. This is a photograph at the test facility before the racks are loaded with commodity. We can see our sprinklers centered between the uprights in every bay. Here's the photograph looking down a longitudinal flue space. You can see our separation from the deflector to the top of storage. We've hidden the piping behind a structural rail. There's just a very small portion of the sprinkler below the rail. So it's very well protected from damage. This is the plan view from the test report, looking down from above. You can see our sprinklers are centered between the 4 pallets. We have the igniter on the face of the storage. We have an 8-foot aisle to the target array. Again, looking down the longitudinal flue space, here's our horizontal barrier. Here's our sprinkler with about 8 inches of separation from the top of the storage. This is the elevation view. So we see our sprinklers installed 20 feet above the floor. Now our ceiling sprinklers only have to protect 15 feet of storage. So we have taken the volatility of this project, put a virtual floor in of protection, and reduced the required job that the ceiling sprinklers have to do. Virtually cut the problem in half. Here is our friend, the exposed expanded polystyrene meat tray. This is a photograph of the test with the racks fully loaded. This represents about 115,000 US dollars of our boss's money, El Jefe's dinero. It's a very exciting day. When we light this, we don't know if there will be a tomorrow for us or not, if we burn this up and we're not successful. Here's the video of this test number 1 at UL. Underwriter Laboratory is very good at running fire tests, but not so good at making video. So forgive the motion of the camera towards the end of the test. UL starts the fire, has the igniter at the face in hopes that the fire will stay on the face and go past our horizontal barrier, and they will make us fail. That's why they are so good at running tests. We see time and time again the fire climb the vertical face of the storage in about 45 seconds, over and over and over. Very repeatable process. Here's our horizontal barrier. We're beginning to see the T formation. Sprinklers are holding. And in a very small amount of time, the water spray from the discharge of the sprinklers pushes this fire down to the first level. Only 2 sprinklers are open. So after 1 minute of spray discharge, this is when the water flow switch, the contacts close and sends the first alarm. As you can see, at the 1 minute point, the fire is virtually over. It's well contained. This is a wildly successful fire test and gives us more money to do future testing. Here's a photograph after the test. You can see that the fire was well contained within the 2 uprights, or where our 2 sprinklers operated. Notice we cannot see through the rack. So much commodity is left. That's very important when we're evaluating the performance of this system. So our first sprinkler operated at 49 seconds. Here's our igniter. The second sprinkler operated at 52 seconds. So we need to use a metric or a scale to measure our success. And we chose to use the same scale that Underwriter Laboratory uses to list or approve any sprinkler that we would go to their laboratory for. We wanted to make sure there was no sustained combustion at the outer edges of the target array. The fire did not jump to the target at all. No sustained combustion at the far end of the racks. You can see that the loss of commodity was very well contained where the sprinklers operated. No sprinkler should open outside the fire area. It's very well contained with 2 sprinklers. We are allowed to have a 1 minute average seal temperature of 1,000 degrees Fahrenheit. Our actual measurement was 102 degrees. So it was very successful, which allowed us to get more money from El Jefe and go and test carton unexpanded plastics. We wanted to challenge ourselves and make the test more difficult. We raised the ceiling to 48 feet, and we raised the horizontal barrier from 20 feet to 30 feet to have it more difficult and to have it delay the operation of the sprinklers. We wanted to test the capability of the N252 EC sprinkler, so we installed these at the ceiling. Remember, the ceiling sprinklers only need to protect the storage that's above the horizontal barrier, and we only have 13 feet of storage above that barrier. We use the same sprinkler in the rack, so this makes the fire sprinkler product very versatile. It can be installed in the ceiling and at the rack. One box of sprinklers in both locations. Here's a view down the longitudinal flue space. You can see our horizontal barrier. You can see we changed the color of our commodity to represent the corrugated cardboard carton. We've made the test more difficult again with a 4-foot aisle width, making it easier to jump the aisle. These are our sprinklers, once again, centered between the storage between the uprights. Again, looking down the longitudinal flue space, our deflector is very close to the top of the storage. Here's the elevation view. You can see we moved the barrier to 30 feet, 48-foot ceiling. We only have 13 feet of storage above the horizontal barrier. And in one of the tests, we relocated the igniter from the transverse flue space to the face of the storage. Again, Underwriter Laboratory is trying to get the fire to stay on the face of the commodity, not go under the horizontal barrier. They're trying to get us to fail. We need several test points and successful tests at each location in order to get a listing for the product. This is our commodity, the crystal polystyrene cocktail glass, upside down and divided corrugated cartons on wood pallets. Here's a photograph of the racks fully loaded. You can see our horizontal barrier, our target array. This is our carton unexpanded plastic video. We have a picture in a picture at the 30-foot elevation, so we can actually see the spray discharge from the sprinklers when they operate. You can see the droplets spraying beyond the target array here. Again, the spray discharge just pushes this fire down to the floor. Notice the sheeting of the water down the exterior surfaces of the storage commodity. This is at the 1 minute point. After 1 minute of spray discharge, This is when the water flow switch closes its contacts and sends the first alarm, the first signal, the first time the bell is rung. And the event is virtually over. There's literally no fire left for the fire department to come and deal with. Here's the steel photograph during the fire test from 2 views. Here's a photograph of the elevation after the fire test. You can see we've lost some commodity, but it's only half as wide as the previous test. So there's still a very minimum loss of commodity during this test. The fire is very well contained. Please note that we had no charring to the edges of the uprights of the racks where the sprinklers were operating. This shows the wonderful mechanism that is provided to us as fire protection, fire sprinkler people, by corrugated cardboard packaging. This cardboard soaks up the water droplets and stops the horizontal spread of fire. So it's a wonderful mechanism of suppression and control. So when we see customers take their products, like car bumpers, out of a corrugated cardboard box and put it in a plastic bag, they have unwittingly changed their commodity classification from a carton commodity to something that's much more volatile with an exposed expanded plastic. We see this all the time. At IKEA, you go to buy the furniture that you put together yourself, the bookcases and things. Years ago, when my daughter went to university, we bought furniture for her dormitory room, and everything came in a corrugated cardboard box. Now today, you go to buy the same furniture at IKEA, and you pick the items, and they bring them off the shelves, and they come down. They're all shrink wrapped in a hard plastic wrapper with the banding on it, and they have gotten rid of this wonderful mechanism of suppression and made it much more difficult for the fire sprinklers to do the job. We see this happen all the time, and people don't change their fire sprinkler system to keep up with this dramatic change in the commodities we see. So here's our results. The 2 sprinklers over the ignition point opened at 1:15 seconds. We had this 1 sprinkler open at 1:14. And this deserves some explanation. Solder element sprinklers are much faster than glass bulb element sprinklers. However, the glass bulb sprinklers have a very narrow band of operation, or a very small standard deviation from minimum to maximum temperature where they operate. Links are faster, but they have a broader range of when they will operate at what temperature to the next. So this sprinkler here was just simply a slightly faster sprinkler. It had less solder permeation between the 2 plates that hold it together by a little percent, a percent or 2 less area than these 2 sprinklers. So they all operate with the same response time index, and we're allowed this range or deviation from when they actually operate. As such, the standard committee requires us to have a safety factor because we opened an extra sprinkler. So we calculate 4 sprinklers in our hydraulic component area for this NRAC EC system. When we look at our performance criteria compared to UL standard, again, we did not jump to the target, even though it was only 4 feet away. We had no sustained combustions to the end of the racks. It was very well contained vertically. No sprinkler should operate at the outer edges. We had 1, but that was an anomaly. Our maximum 1-minute average steel temperature, again, we were allowed 1,000 degrees. We were actually measured at 82 degrees Fahrenheit. So again, a wildly successful test. We've had more than 3 in each of these categories to submit to the committee for consideration, and is now included in the 2019 edition. The 2019 edition will be published this September, but you can begin using it now under the new technology clause that's in the standard 1.5 and 1.6 right now today. So Okay, muchas gracias. Are there questions?
Bueno, gracias David. No, básicamente era eso, nueva tecnología. Javier, por favor. Ok. ¿Cómo? Si quieres yo se la traduzco.
Bueno, muchas gracias por la conferencia. La pregunta es la siguiente, muchísimas gracias por la conferencia. El espaciamiento entre el tope de la mercancía y el deflector en los rociadores sin rack, los rociadores en estantería, NFPA 13 lo determina hasta 2016 que sea mínimo 6 pulgadas o 15 centímetros. Pero observando la conferencia, hay modificación en que el espaciamiento ahora puede ser 4 pulgadas y en otros casos 8 pulgadas. ¿Ese espaciamiento va a ser solamente para estos rociadores con la lámina vertical o NFPA 13 va a cambiar el requisito para todos los rociadores sin rack? Y la separación entre estos rociadores de cobertura extendida va a tener un mínimo que va a ser igual a 2.4 metros o se continuará.
Sí, 8 feet minimum,
Yeah.
10 feet maximum.
Okay.
There is new FM global system with K22, K25, 4 feet, 1.1 inches. They do not keep the sprinklers spray on one another because one sprinkler will always be above the point of division. So one sprinkler will always work very quickly. But it's very expensive. Many sprinklers. We think ours is better to reduce the cost, reduce the number of targets. So you have your choice. We are at FM Global today testing the system to be included in the FM standards. Maybe next year I will come back to the
Okay. Muchas gracias.
Básicamente esas 4 pulgadas que la da el deflector para no descarga tan horizontal es así como unidad FPA y FPA tenía 15 pulgadas. Se había requisito, pero solamente para los platos.
Muchas gracias también por la conferencia. Uno de los problemas que tenemos con los INRAC es el espacio para poder entrar las tuberías por el flow space y por el flujo transversal, por todo eso, ¿no? Por lo general los cálculos, lo que hemos visto en una estantería normal es en 1,5, 2 pulgadas máximo. En estas pruebas que hicieron, ¿en qué diámetro les está dando ese, o más o menos, me imagino como son más flujo y todo, en qué diámetro les está dando ese principal que mostraste en la foto donde tenía las barreras?
Yes. We only came from one direction to the end. Many customers will come down and down this way and have 2-inch stacking just for that space reduction. And we always come out the side, never the bottom. And then this raises the sprinkler to the fitting maintenance.
Bueno, nada, básicamente era eso. Muchísimas gracias y saben que lo que necesiten. Nosotros tenemos un departamento técnico. David por 23 años hace 23 años está con nosotros. Por muchísimos años fue el director de ese comité técnico, donde cada ingeniero que participa, excepto Antonio, que recién empieza con nosotros, no tiene menos de 25 años en ingeniería contra incendio. Ellos se turnan uno cada semana para contestar dudas, preguntas, ya sea por correo, pueden escribir a mí, a ellos directamente, pero siempre hay una persona contestando dudas, preguntas, netamente de ingeniería. No es, muchas veces he visto de donde la respuesta a lo mejor es les ofrece un rociador Viking, un rociador Taiko, Taudi, o sea, porque nosotros no hacemos o tiene una mejor opción con otra marca, es 100% de ingeniería, así que con toda confianza pueden utilizar esa herramienta. Bueno, muchísimas gracias.
David, muchas gracias. Jesús, muchas gracias por acompañarnos, por abrir este espacio para la asociación. En nombre de todos, pues mil gracias. En nombre de todos, mil gracias por ese apoyo que nos han dado. Muy contentos de contar con ustedes y como le decía ahorita Antonio, cuenten con nosotros cada vez que estén aquí en Colombia y pues a todos nuestros asociados siempre les decimos lo mismo, pues ANRAS está aquí para ayudarlos y apoyarlos en lo que en nuestro poder esté. Muchas gracias. Vamos ahora a tener un break y luego tenemos una conferencia del ingeniero José Joaquín. Tenemos ahí un gapcito que él venía en el vuelo de las 12 y se le retrasó un poco, pero ya hablé con él hace unos minutos y ya viene en camino. Yo creo que cosa de 20 minuticos tenemos la conferencia con él para luego ya dar paso a nuestra asamblea. Entonces, podemos estirar las piernas un ratico mientras esperamos. Our pleasure.
I'm glad.
Hi. This is yours. And este, sí, también. Y este es Antonio. No creo. Pero muchas gracias. No, porque ahorita no tenemos ya lo que presenta. Si acaso te aviso, pero no. Hugo.